Section 1. Introduction. Understanding one-to-one functions. Imagine a cosmic dance of numbers. Each number in a set wants a unique partner from another set. This special pairing is what we call a one-to-one function in the world of mathematics. In simple terms, a one-to-one function ensures that no two inputs share the same output. It's like assigning each star in a constellation its own unique name. No confusion, no duplicates. Think of a vending machine. You press a specific button, you get the specific snack you desire. That's a one-to-one function in action. One-to-one functions are crucial in algebra and beyond. They help us understand relationships between variables and solve equations with elegance. Let's delve deeper into this fascinating concept. Section 2. The horizontal line test, a visual aid. Graphs are powerful tools for visualizing mathematical concepts. When it comes to one-to-one functions, the horizontal line test is our trusted sidekick. Imagine drawing horizontal lines across the graph of a function. If any line intersects the graph at more than one point, then the function is not one-to-one. Why? Because it means that two different inputs, or x values, are producing the same output, or y value. This violates the fundamental rule of one-to-one functions. Each input deserves its own unique output. For instance, the graph of y equals x squared fails the horizontal line test. A horizontal line drawn at y equals 4 intersects the graph at 2 points, x equals 2 and x equals -2. This indicates that the function is not one-to-one. On the other hand, the graph of y equals 2x plus 1 passes the horizontal line test with flying colors. Any horizontal line you draw will intersect the graph at most once, confirming its one-to-one nature. Section 3. Properties of one-to-one functions. One-to-one functions possess unique characteristics that distinguish them in the mathematical landscape. First, they always have an inverse function, which is like their mirror image. We'll explore inverse functions in more detail later. Second, their graphs exhibit a specific pattern. As we move from left to right, the graph either consistently rises or strictly increases, or consistently falls or strictly decreases. This ensures that no horizontal line can sneakily intersect the graph at multiple points. Think of a one-to-one function as a cosmic staircase. Each step you take upward corresponds to a unique step to the right. There's no turning back, no skipping steps. These properties are essential for understanding the behavior of one-to-one functions and their applications in various mathematical contexts. Section 4. Identifying one-to-one functions, algebraic and graphical methods. Armed with the knowledge of the horizontal line test and the properties of one-to-one functions, we can now embark on the quest to identify them. Algebraically, we can check if a function is one-to-one by examining its equation. If we can prove that f of x1 equals f of x2 implies x1 equals x2, then the function is one-to-one. Graphically, we can simply employ the horizontal line test. If no horizontal line intersects the graph at more than one point, then the function earns the one-to-one badge of honor. It's like solving a cosmic puzzle. We can use either logic or visual cues to determine if a function possesses the special property of being one-to-one. Section 5. Inverse functions, unveiling the reverse. Every one-to-one function has a secret twin, its inverse function. Denoted as f inverse of x, the inverse function reverses the mapping of the original function. It's like hitting the rewind button on a cosmic movie. If f of a equals b, then f inverse of b equals a. The input and output switch places, revealing the original input that led to a specific output. The graphs of a function and its inverse are symmetrical about the line y equals x. It's like reflecting the graph across a cosmic mirror. Inverse functions are essential in various fields, from cryptography to computer science. They allow us to decode messages, reverse processes, and gain deeper insights into the nature of functions. Section 6. Real-world examples. One-to-one functions in action. One-to-one functions are not just abstract mathematical concepts, they permeate our everyday lives in subtle and profound ways. Consider the act of assigning social security numbers. Each individual is assigned a unique 9-digit number, ensuring that no two people share the same identification. That's a one-to-one function in action, safeguarding our identities in a vast sea of data. In cryptography, one-to-one functions are the backbone of secure communication. Encryption algorithms rely on one-to-one mappings to transform plaintext messages into unreadable ciphertext, protecting sensitive information from prying eyes. From the intricate workings of our bodies to the vast expanse of the cosmos, one-to-one functions play a fundamental role in shaping our understanding of the world. Section 7. Practice makes perfect, testing your understanding. Now that we've explored the concept of one-to-one functions in detail, it's time to put our knowledge to the test. Try these practice questions to solidify your understanding. 1. Determine if the function f of x equals 3x minus 5 is one-to-one. Justify your answer. 2. Given the function g of x equals x plus 1 squared, is it a one-to-one function? Explain your reasoning. 3. Find the inverse of the function h of x equals 4x plus 7. Verify that the inverse function is indeed the inverse of the original function. These questions will challenge you to apply the concepts we've discussed and develop your intuition about one-to-one functions. Section 8. Conclusion: the significance of one-to-one functions. One-to-one functions are not merely mathematical curiosities. They are fundamental concepts that underpin many areas of mathematics and its applications. They allow us to establish unique relationships between variables, solve equations with precision, and unravel the mysteries of inverse functions. Their presence can be felt in fields as diverse as cryptography, computer science, and everyday life. By understanding one-to-one functions, we gain a deeper appreciation for the elegance and power of mathematics and its ability to describe the world around us. Section 9. Answers and explanations. Practice questions 1. The function f of x equals 3x minus 5 is one-to-one. To prove this algebraically, let's assume f of x1 equals f of x2. This implies 3x1 minus 5 equals 3x2 minus 5. Simplifying the equation, we get x1 equals x2. This satisfies the condition for a one-to-one function, as equal outputs imply equal inputs. 2. The function g of x equals x plus 1 squared is not a one-to-one function. We can see this by considering the inputs x equals 1 and x equals negative 3. Both inputs produce the same output. G of 1 equals 1 plus 1 squared equals 4, and g of negative 3 equals negative 3 plus 1 squared equals 4. This violates the one-to-one property, as different inputs result in the same output. 3. The inverse of the function h of x equals 4x plus 7 is h inverse of x equals x minus 7 divided by 4. To find the inverse, we first replace h of x with yy equals 4x plus 7. Then we swap x and y for x equals 4y plus 7. Solving for y, we get y equals x minus 7 divided by 4. Finally, we replace y with h inverse of x equals x minus 7 divided by 4. To verify that this is indeed the inverse function, we can check if h of h inverse of x equals x and h inverse of h of x equals x. By substituting the expressions for h of x and h inverse of x, we can confirm that both equations hold true.